Hello, this is Brian Brown at Hananiga High School, and today we'll be looking at our third day of notes related to ideas from Chapter 3. And today we'll be continuing on with the discussion about making measurements. Now, last we talked when we made a measurement, like in the slide where we had the three graduated cylinders. The very first graduated cylinder we said had a volume of 5.73 milliliters. Now, if you think about that measurement that we took, the 5 and the 7 were known or certain digits. Everybody who looked at it realized it was between 5 and 6, so more than 5, less than 6. It was between the 0.7 and the 0.8, so it was definitely 0.7. And then the last digit, the 3, is where we estimated. So when we make a measurement, we're going to write down only digits that were a significant and an important part of the measurement in most cases. So we're going to have those digits that are certain, where everybody would have said it was definitely 5.7. And then we had our estimated digit, which was the 3 in the hundredths column. So it looked to us like it was a little bit less than halfway. So what we have here in this measurement is three digits, the 5, the 7, and then our estimated digit, the 3, that were all a significant part of our measurement. Now we're going to call these significant figures or significant digits. It's basically digits in a number that were significant parts of the measurement. And it's always going to be all of the known or certain digits plus the one estimated digit. And those are always going to be significant. Now sometimes we'll have numbers in a measurement that really all they are is a placeholder. They're trying to show us where a decimal is. And that's something we'll look at more a little bit later. So none of the digits in this particular case, the 5, the 7, or the 3, were actually just to tell us where the decimal is. They were all part of our measurement that we made. And remember, the significant digits are all the known digits plus the uncertain or estimated digit. So we would say this measurement had three significant figures. And that's something that we're going to basically practice at making measurements. And at the same time, we're also going to think about, well, how many significant digits would be in that measurement? And that's actually where we're going to go more in our next set of notes. So let's say we look at this measurement and we thought it was 1.74. So we thought it was slightly under half. So the 1 and the 7 and the 4 or the 5, depending on how you measured it, would be all significant digits. The 1 and the 7 would be certain digits, and the 4 or the 5, depending on whether you thought it was at the half or just under the half, would be an estimated or uncertain digit. So 1.74, 1.75, both of those would be valid measurements for this. And that's because we're estimating in that last digit to get a more precise measurement. Well, both of these numbers would have three significant digits. So remember, all of our exact or known digits plus our estimate would be significant. So measuring this bar with this ruler, we would end up with a number that we say has three significant digits. Now, let's say we're using the same ruler to measure two different bars. So what are the lengths of the objects pictured below? So first we take a look at the shorter purple one, and I realize, well, it's less than 1. Looks like it's a little bit more than 0.7, and I think it's just slightly under half. So I'm going to call it 0.73 centimeters. Now remember, you might vary slightly from me. You might have said, well, I think it's 0.74, but they're both valid measurements using this ruler. And then our longer lime green line here, well, that's somewhere between 2 and 3, and it's definitely above the 0.9, so I'm certain it's 2.9 something. Well, to me, it looks like it's a little under half, so I put 2.94. Now, once again, you might say, no, that's dead in the center, so I'm going to call that 2.95. Well, that would be a valid measurement with this device as well. Now, even though we're using the same device, now look at how many significant figures are in each of these measurements. Now our shorter measurement that was less than 1, we had 0.73. Now the 0 here really doesn't matter if we put it. I mean, we could not even write that 0 if we wanted, because that 0 is an example of a placeholder. It's this there to help us see where the decimal is. But it was definitely zero point 0.7, and it was around 0.03 100ths. So 0.73 would have two significant digits. And remember, that means the 7 was a certain digit, the 3 was a valid estimated digit, and we would get two significant digits. Somebody might have had 0.72 or 0.73, 0.74, and all of those I would consider valid, good measurements, but they would all have two significant digits. Now in the lime green one, which was 0.294, it's kind of the same idea. We're all going to get 2, and we all know it's more than 9/10 but less than 3. But that last digit is where we're going to estimate. And in that estimation, it might have been 0.93 or 0.94, 0.95. They're all perfectly valid. They just vary a small degree from each other. but that estimate is a part of our significance in this number. So that estimated digit would also be significant. So in this case, when we were measuring something with this ruler that was more than 1, we ended up getting 3 significant digits or 3 significant figures. So even with the same device, depending on whether we're measuring something smaller or something larger, we're going to get a different number of significant figures. But what you need to understand is how this is related to the concept of precision or reproducibility. And that's easier to see that idea when we look at this situation where we're using 2 entirely different rulers. They're going to have a different smallest division, so we're going to record to a different number of decimal places. So remember, measurement rule is first you establish what is the smallest division. So in this particular case, I see a 1 and I see a 2, and there's 10 divisions in between there. So you know each one of these divisions is a tenth of a centimeter. So I know the top ruler has a smallest division of 0.1 centimeters. Well, if it reads to the nearest 0.1, that means I can estimate to the nearest 100th centimeters. Now in the bottom ruler, now my smallest division is 1 centimeter. And reading to 1 decimal place better than that would be the tenths. So in this particular case, I can read to the tenths of a centimeter when I'm recording my measurements. So those are 2 different things. The top one, I'm going to go to 2 decimal places, the hundredths. The bottom one, I'm going to only go to 1 decimal place. That would be the tenths. So when I make my measurement here, I take a look at where I'm at. I'm definitely bigger than 2. I'm definitely bigger than 0.9, but not up to the 3. So when I look at that, I say it's like 2.94 centimeters would be what I would measure. Well, I went to 2 decimal places like I was supposed to, so it was a valid measurement. And, or I should say, so it was a precise measurement. I went to the right number of decimal places, and it was a valid measurement because it clearly is between 2.9 and 3.0. And my eyes are good enough to estimate it's about 4 100ths. When I go to the bottom measurement, even though I'm measuring the exact same object, because my ruler's not as good, my precision shouldn't be as good. So in this particular case, it reads the nearest 1 centimeter, so I can estimate to the nearest tenth. So the best I can claim about this is it looks like it's less than 3, so I'm going to say it's 2.9 centimeters. So even though I'm measuring the same object, because my 2 measuring devices don't measure to the same precision, I'm going to get 2 slightly different measurements. Now, both of these are valid based upon those devices, but they are slightly different measurements because the ruler is not as good in the bottom case. So think about those 2 situations in terms of significant digits. The top one, 2.94, would have 3 significant digits, 2 known and 1 uncertain or estimated digit. The bottom one only had 2 significant digits. The 2 was a known. We knew it was between the 2 and the 3, and my estimate was in the tenths. So that's only going to have 2 significant digits. So one thing you should fundamentally realize here is when you look at a measured value and count how many of the digits are significant, the more significant digits you have, the more precise the measurement was. So accuracy is all about whether it's right. Precision is really all about reproducibility. And the more decimal places I can record to with the measuring device, the closer my grouping of numbers are going to be as long as they were accurately measured with that measuring device. Now, to kind of drive home this point and counting significant digits and understanding when a digit was a certain digit, when it was an estimated digit, and when it could just be a placeholder, we're going to look at 2 graduated cylinders with the same amount of liquid in it. Now, first we have the graduated cylinder on our left. Now, first thing you're supposed to do for measurement rule is find out what's the smallest division. Well, the smallest division here is 100. So between 100 and 200, there's only 1 division. So hundreds is where my smallest division is here. So this is not a very good graduated cylinder. It reads to the nearest 100th of a milliliters. So if I read to the hundreds, that means I can estimate to 1 decimal place better. Well, what is 1 decimal place to the right of the hundreds column? Well, 1 decimal place to the right of the hundreds column, which would be right here, would be this decimal place, which is the tens. So when I'm using this measuring device, I should be able to estimate to the tens. Now, when I look at that, it looks to me like it's well under half, but yet it's not super close to the 100. So I would guess about 120 milliliters. So that would be how, with this measuring device, I would measure. Now, we know that the 1 is definite. That's certain. Everybody would say that it's definitely between 100 and 200. And my estimated digit was here, the 2. So this really only had 2 significant digits. That 0 is there because I want to have 1 in the hundreds and 2 in the tens. I can't just write 12 centimeters because now I've changed my number. So that 0 is an example of a non-measured place holder. All it's there is to tell me where the decimal is supposed to be at. But that 0 wasn't actually measured. Now, if I take the same amount of liquid and pour it into a new graduated cylinder, now in this graduated cylinder, it reads to the nearest tens. And if it reads the nearest tens, then I can estimate to the ones. And it looks to me like it's definitely more than 100. It looks like it's on the 20. And it looks like it's dead. The bottom of that meniscus is right on the 20. So I would think I have 0 ones. So now I'm going to get 120 milliliters. But now I mean I'm certain about the ones, I'm certain about the two or the tens, and I think there are 0 ones, and that 0 is actually a significant part of my measurement. I think there's 0 in the ones place. So this is supposed to have 3 significant digits. How do I tell the 0 on the left doesn't count and the 0 on the right does? Well, there's a really quick, easy way to do this that you've probably never done before in math class because it seems like it's a waste of time. But I could actually stick a decimal there. Now it's still 120, and if I understood sig fig rules and measurements in chemistry, and we're going to get into this more tomorrow, one of the things we're going to say is a 0 at the end of the number only counts if there's a decimal. Well, there's a decimal shown in this number. And now notice it's not 120.0. I didn't write it that way. I just put 120 decimal point. And what that is telling somebody is that 0 was a valid part of my measurement. And since it was my last significant digit, that must be where my uncertainty is. So that little decimal point can help us tell that the measurement on the right was a better, more precise number than the one on the left. Because the one on the left is like 120 plus or minus 10, and the one on the right is like 120 plus or minus 1. It's a more precise measurement. It's not only more valid, but it's definitely more precise. And that's something we're going to end up looking more at tomorrow. Now, when you make the measurement, you know what you mean. You would understand that the one on the right had 3 significant digits and the one on the left only had 2. But when you're reading somebody else's measurement, we have to be very careful when we write zeros at the end of a number. And that ends our third day of notes.